algebra. What up? Hope you enjoyed that. So lesson 3, we are talking about advanced factoring strategies for quadratic expressions. Let's just go. So your opening exercise. Carlos wants to build a sandbox for his little brother. He is deciding between a square sandbox with side lengths that can be represented by x plus 3 units and a rectangular sandbox with a length 1 unit more than the side of the square and width 1 unit less than the side of the square. Okay, the pictures are right there, right? All right, so let's talk about that. Carlos thinks the area should be the same because 1 unit is just removed from one side to the other. Do you agree that the two areas should be the same? Why or why not? This is something if we were in class we would talk about it. Okay? Some of you guys are going to think, yeah, that sounds right. And some of you guys will be like, I don't think so. So that's really a discussion point. So how would you write the expressions that represent the length and the width of the rectangular sandbox in terms of the side length of the square? So we've got length and width. You can write them like x plus 3 plus 1 and x plus 3 minus 1. You could write that as x plus 4 and x plus 2. So that would work for length and width. But really what I want to see at this point is this one. Okay, that's what I'd like to see. So if you use the expressions for length and width represented in terms of the side length of the square, can you then write the area of the rectangle in the same terms? So I'm using this one, and I'm going to say the area is x plus 3 plus 1 times x plus 3 minus 1. Cool? All right, write that down. Moving to the next page. All right, this next question asks, how can this expression be seen as the product of a sum and difference? This is what we have so far. I'm just rewriting it because I need to see it. So what we're going to do, this is what I'm looking for. I'm going to make this an A and this a B. So what we're really going to have is a plus B and a minus B, right? Can you now rewrite the area expression for the rectangle as the difference of squares? Well, of course I can, because the difference of squares is a squared minus b squared. And since a is x plus 3 and b is 1, of course I don't have to write that, correct? It's pretty cool. So this right here is your difference of squares. Now it says here, look carefully at your answer to the last question. What does it tell you about the areas of the two shapes? Well, since the area of the square, the area of the little square is x plus 3 times x plus 3, which is x plus 3 squared, then the area of the rectangle is right here. Sorry, this is the area of the square. This is the area of the rectangle. The question says, look carefully at your answer to the last question. What does it tell you about the areas of the two shapes? Since the area of the square is this, and the area of the rectangle is that, this shows that the area of the square is one more square unit than the area of the rectangle. So this right here is 1 more square unit than the area of the rectangle, because we're subtracting 1 square unit from it, right? All right, can you verify that our algebra is correct using a diagram or a visual display? Hold on, I'm going to get back to you and just draw it real quick. Okay, I just drew x plus 3 times x plus 3, which is right here. Then I drew x plus 3 plus 1 times x plus 3 minus 1 right here. And if we look over here in this corner, which shaded here is 1, 2, 3, 4, 5, 6, 7, 8, 9 square units. And if we look right here, 1, 2, 3, 4, 5, 6, 7, 8, 8 square units. So we are off by 1 square unit. Crazy, huh? Okay, what that tells us is you really have to watch your math. When you think you're just adding 1 and subtracting 1, you have to go through the work to actually get the answer and not just make assumptions by, well, I'm just adding a little bit here and subtracting a little bit there. Okay? Okay. So let's look here. In lesson 2, we saw that factoring is the reverse process of multiplication. We factor a polynomial by reversing the distribution process. Consider the following example of multiplication. Here we foiled this. I have first, outer, inner, last. Collect those like terms. I get 8x squared plus 8x plus 15. When we compare the numbers in the factored form with the numbers in the expanded form, we see that 15 is the product of two numbers, 3 and 5, and 8 is their sum. The latter is even more obvious when we look at the expanded form before the like terms are combined. Can you explain why that relationship exists? I don't know, the why really doesn't bother me so much, but we can look at it. So the coefficient of the term with a variable to the first degree. So if we have this, for example, okay, this is my coefficient of the term to the first degree, which is called the linear term, is 8, is actually the sum of the two constant terms of the binomials. So when we factor it, it's actually the sum of the two constant terms, the binomials, right there. Okay? The constant term of the quadratic expression, which is right here, is the product of the two constant terms of the binomials. So 3 times 5 is 15, 3 plus 5 is 8. And that's how it is every single time. Okay? So now let's compare the expansion of this binomial as a product to the one we just did. But see here, I've got a coefficient in front of these. So what I see here is if I FOIL it, I've got first, outer, inner, and last. So I get 2x squared plus 13x plus 15. Here, 2 times 15 is 30. Right? So I need, and here I've got 13. Here I've got 30, and here I have 13. So what we see here, 13 can break into 10 plus 3, and 10 times 3 is 30. Let's just draw that. So here, 2 times 15 is 30. And 30 breaks into 3 times 10. But 3 plus 10 is 13. So I've got 13 and 30. It's sort of magic. So we have coefficients on both the x terms, and one of them is not 1. So we have a 2 and a 1 as the factors, the leading coefficients right here, 2 and 1 in the expanded form, and 3 and 5 in the constant term. So get ready for quadratic expressions in factor form where neither the x term and the coefficients are 1. So really, how can we talk about how this is different from the first example? I sort of explained it up high. It's only different that I don't have a 1 in front of each variable in the binomials. This right here throws everything off. Okay? So when I have that in a quadratic form, and I'm trying to factor it, I really look at this product. 2 times 15 is 30, and I break that into two numbers. I've got 1 times 30, 2 times 15, 3 times 10, and I look for the one that sums to the middle term. Okay, the previous example I had, let me pull it up, when I had x plus 3 and x plus 5, if I put that into quadratic, x squared plus 8x plus 15, I still have a 1 here. So I'm really doing 1 times 15, which is 15. And then I break that into its factors, 1 times 15, 3 times 5, and I find the one that adds together to the middle term. Okay, so it's the same process. All right, I am going to skip a few of the next things and go straight to a different explanation. Okay, so stick with me. The one thing I want to talk about right now is when you factor something, what the plus and minuses are going to be. So let's do this. I've got ax squared plus bx plus c. So these signs right here mean something. When I've got a plus and a plus, this one means that everything's the same. This one means they're both plus. So when I factor this, I'm going to have x plus, I don't know, a smiley face, and x plus a frowny face. This is what I mean by both of them are the same and they are both pluses. Okay? Now let's say I have ax squared minus bx plus c. What does this mean? The same, just like before. And this one means they're both negative. So if I were to factor it, I'd have x minus a smiley face and x minus a frowny face. They're both the same, and they're both negative. Okay, let's try one more. Ax squared plus bx minus c. So that sign means that they're going to be different signs in the binomials. And this sign means the bigger has to be positive. So if we factored it, it's going to be plus, I don't know, and minus. So they're different. So different, and the bigger has to be positive, because if we were to FOIL this, outer is minus, plus, and minus. So because my bigger is positive, when I add these together, if I've got more positive than negative, my answer is going to be positive. Last one, ax squared minus bx minus c. Remember, different, and bigger is negative. So if we factored it, we would get x minus something, x plus something. And if we FOILed it, x squared plus smiley face, goodness, x minus smiley face x minus smiley face squared. Because the bigger one is negative, when I collected these like terms together, if this one is bigger and you add them together, it's going to remain negative. All right, let's practice. So this means they're different. The bigger term is going to be negative. Okay, so let's do, I say this is A times C. 3 times negative 8 is negative 24. Let's factor negative 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. We're looking for two numbers that add together to negative 2. If I go 4 times negative 6, I get negative 24. And 4 plus negative 6 is negative 2. So I've got it. These are the terms I'm going to use. Let's go ahead and split it up. 3x squared, I'm going to use these two terms. I'm going to go ahead and write minus 6x plus 4x minus 8. Because negative 6x plus 4x equals negative 2x. So all I'm doing is expanding that quadratic, that polynomial. I'm expanding the middle term. Okay? I'm going to ignore this for a little bit. We'll come back to it. So I have 3x squared minus 6x plus 4x minus 8. I'm now going to factor this by grouping. So I'm going to look at this binomial and take the GCF out. Looks like I can take a 3 and an x. What I have left here is an x. What I have left here is a minus 2. I'm going to look at this binomial. Looks like I can factor out a 2. I'm left with, oh no, I can factor out a 4. I'm left with x minus 2. Now if you look, these are the same. So I'm going to factor out, from this term, I'm going to factor out an x minus 2. And from this term, I'm going to factor out an x minus 2. And I have left 3x plus 4. And I'm done. I can FOIL it to double check. 3x squared plus 4x minus 6x minus 8. 3x squared minus 2x minus 8. I got it. So this right here is my answer. Okay, let's try number 2. Let me find a fresh, there we are. So number 2, I'm going to go ahead and, again, negative 24, and I need to break it into things that add to 10. 2 times 12, looks like I can do negative 2 and 12, and add that to get 10. So let's use that negative 2 and 12 to split up our center term. So 3x squared, I'm going to go ahead and put the 12 there, because I can factor something out of the 12 and the 3. There we go. So now group these two together and those two together. I'm going to factor out from this binomial a 3x, and I'm left with x plus 4. And I'm going to factor out of this one, and I'm going to factor out a negative 2. It always has to be a negative. If there's negative there, I'm factoring out a negative here. And I'm left with x plus 4. And look, these are the same again. So from this term, I'm going to factor out an x plus 4, and I'm left with a 3x. And from this term, I'm going to factor out the same x plus 4, and I'm left with a minus 2. And that is my answer. FOIL it to check. 3x squared minus 2x plus 12x minus 8 is 3x squared plus 10x minus 8. There we go. All right, let's try this one. Actually, I should say, the first thing I do is I look at this whole thing and see if I can factor something out. Okay, 3, 1, and negative 14. There's not a greatest common factor that I can go there. So I'm going to work down here. I have 3 times negative 14, negative 42. So I need numbers that multiply to 42 and add to 1. Let's see. 1, 2 times 21, 3 times 14, 4, 5, 6 times 7. There we go. So I need a positive 1 in the middle. Let's go ahead and make that negative. So when I add them together, I get a 1. So let's try it. I have 3, well, sorry, no parentheses yet. I'm going to split up 3x squared. 6 is factorable with that. So minus 6x plus 7x minus 14. Go ahead and group the first two and the last two. Factor out your GCF. I have a 3x, and I'm left with x minus 2. I'm going to factor out a 7, and I'm left with x minus 2. These will always match if you've done it correctly. So I'm now going to factor from the first term an x minus 2, and I'm left with a 3x. And from the second term an x minus 2, and I'm left with a 7. And there is our answer. All right, this next one, again, I can factor nothing out of those. So I'm going to go ahead and multiply these. 2 times negative 36 is negative 72. This is going to be a little more challenging. And if it takes too long, try the next one. So I need to add to 21, negative 21. So let's see. 1, 2, I need a bigger number. Would 4 work? Hold on. All right, I just did some division. So 2 times 36, 3 times 24, 4 times 18. One of these has to be negative, so it looks like if I go like this and add those, I would get negative 21. So those are my keepers. So let's go ahead and set up, expand that middle term. 2x squared, can't read that. I need to put the number that's factorable with 2, minus 24x plus 3x minus 36. Okay, group the first 2 and the second 2. I can take a 2x out here, and I'm left with x minus 12. A 3 out here, x minus 12. And lo and behold, these match. So let's go ahead and factor that. Moving down here. X minus 2 factors out of each term, and I get 2x plus 3. There we go. All right, number 5. I have a negative leading term. That's bad. So we need to factor that negative out. It's the first thing I do. Oops, what did I forget? Minus 3x minus 9. Now I'm going to leave that negative out there and just work with everything else. So the first and last term is negative 18. I'm trying to get to negative 3. So 3 times 6. Looks like if I make that a negative, I would add those together and get negative 3, which is good. So 2x squared minus 6x plus 3x minus 9. Go ahead and group the first two and the last two together. And I get negative, I'm going to factor out a 2x here. And I'm left with x minus 3 and a 3 here, x minus 3. Of course, these match, going that way. So I get a negative x minus 3, 2x plus 3. Oh, fractions. Need. All right. Hard one. So I'm trying to get 9 over 16. And remember, when you multiply fractions, you're multiplying across the top and across the bottom. So it looks like if I multiply 3/4 times 3/4, I get 9/16. And if I add that, I get 6/4. So there's our answer. R plus 3/4. R, plus 3/4. R plus 9/16. Group the first two, group the last two. R plus 3/4. 3/4, R plus 3/4. These match. I get R plus 3/4, R plus 3/4. All right, use the structure of these expressions to factor completely. I don't see a pattern there. I really don't want to mess with 6,300. And I don't think I can divide by anything. So this one is super duper difficult unless you see the pattern. I'm going to do it two different ways. First, I'm going to say 10x squared minus 2 times 10 x minus 63. If you see the pattern from what we did in the last lesson, that would work. So we are left with 10x plus 7, 10x minus 9 to get that answer. I mean, I'd be doing this one by sheer force. I'm looking at negative 6,300, and I'd be splitting that up into two numbers that are factorable, which is near impossible, that you're going to add together to get to a negative 20. So that's definitely a challenge problem, right? All right, so let's work on this one. I have negative 3, which I'm going to do 1 times 3 is 2. This right here is y to the 4th power, which is no big deal. I'm still going to do it the same way. Y to the 4th power minus 1y plus 3y, and these are squareds, minus 3. Go ahead and factor by grouping. I've got y squared minus 1 left over, plus 3, y squared minus 1, continue up there. If I factor that out because these match, I have y squared minus 1 times y squared plus 3. Well, if you look at this, that's the difference of perfect squares, so I can factor that again. Y plus 1, y minus 1, y squared plus 3 is my final answer. So this one you should be able to do. This one is a challenge problem. So here it looks like I can factor out a number first, which always makes it easier. If I take out a 3, I'm left with 3x squared minus x minus 4. So now I can factor. These two give me a negative 12. I'm going for a negative 1, so 3 times 4 is 12. If that's negative, I can add them together to get a negative 1. So 3x squared plus 3x minus 4x minus 4. Go ahead and group the first two and the last two. I've got, I can take out a 3x. I'm left with x plus 1. I can take out a negative 4, and I'm left with x plus 1. These match, so go ahead and take them out. So 3x plus 1, 3x minus 4. When you're asked to factor it completely, that needs to come out too. Okay, factored completely is all the pieces and parts, okay? Oh, let's see. Looks like I can take out at least a 2. 8a squared b to the 4th plus 10ab squared minus 3. So here I have a negative 24. And it needs to add to 10. So 2 times 12. This has to be negative. That gives me a 10. 8a squared b to the 4th plus, sorry, I think that would be a minus 2 ab squared plus 12 ab squared minus 3. I always want to put these in an order that I can factor a GCF out after I group them, right? So I can group the first two and the last two and factor out a GCF. So that 2 is hanging out for the party. I'm going to factor out a 2, an a, and a b squared. And I'm left with 4ab squared minus 1. And here I'm going to factor out a negative 3. Nope, positive 3. Sorry. I'm left with 4ab squared minus 1. These match. It's not a mistake. 2 is hanging out there. 4ab squared minus 1 and 2ab squared plus 3. Okay, those are tough. Those are very tough. All right, there we go. Quadratic expressions, ax squared plus bx plus c, that's called standard form. Quadratic expressions, some are not easily factored. The hint will make the job easier. When the leading coefficient is not 1, it's hard. Trial and error is viable, but not the best. Check your answers by foiling when you're done.